Nice to meet you, and thanks all for coming. So it's not a big surprise. I work at Hugging Face. I'm the head of Transformers. So of course I'm going to talk about Transformers. And this morning we finished the integration of the Gemma 3 family models in Transformers. So it's a perfect timing to talk about good practices when integrating, for example, the Gemma family models in the Transformers library. So the first question some of you might be wondering is, why the hell would you do something like that, right? Or maybe not. Maybe everyone knows that's the best thing you can do. Maybe not. So the biggest argument for us is that Transformers has been trying to be the source of truth for as long as we can remember. And the idea is that if a code works in Transformers, it's most likely that it's going to work with many other frameworks. And that's because we strive to have a very good compatibility with every other subfields of AI. So a lot of them were quoted before, but there's, for example, inference. So quite recently, we've become the backend of both TGI and VLM that are, I think, two of the state-of-the-art inference libraries. Then there's training. A lot of the libraries like Ensloth or Axalt or Liger, DeepSpeed, Accelerate are fully compatible with Transformers. There's quantization, where we explore pretty much every single quantization method that's out there. That's open source. There's also research. So there's been work from the NVIDIA team with KVPress or very special generated methods. So shout out to the SynthID talk that was just before. I remember we worked with them a year ago on that. So that's very important, and that's possible because we want to be, when we integrate the model into Transformers, we make sure the code is device agnostic, so that it can run on CPU, GPU, but also TPU, basically any device. And then after that, we also have a pledge to make sure we take care of the maintenance. And that is something that has been going on for 4 years. So if you look at the first BERT model, it is still in the Transformers library, and we still make sure that it passes the test. And that's very cool for the entire ecosystem because models can be built on top of them. So you have, for example, Modern BERT that was released, I think, two months ago. And you can easily compare the results because you still have access to a reproducible code from 4 years ago. Then you have a common API and common features that are pretty familiar to everyone now. So for example, the from pre-train or the tokenizer. Then I think you get a lot of visibility. So Transformers has around 50 million downloads per month. And a lot of the people that are downloading the Transformers library, they are always on the lookout to try new models, new techniques, but also new quantization methods. And finally, I think this is something very important for me because one of the main enablers for all of this is the huge work the team is putting on to make sure we put the model through standardization, simplification, and reproducibility. And it can sound very easy, but it's not always. And people always have their own version of code, and we sometimes have to force our own philosophy onto the contributors. But it has been working pretty well so far. Now, here are the first things that you have to provide if you want to do an integration with Transformers. So something that helps everyone is to compare your model. And recently, all of the models have to be kind of compared with the Llama standard because basically that's the easiest way. And in Transformers, for example, a good way that we found is to use, well, inheritance, which here is an example of, for example, the Gemma 3 that inherits from the Gemma 3 attention layer that inherits from the Gemma 2 attention layer. And so this helps identify which layers are different. So here I can just know there's QK, Q norm and K norm. These are the only different layers, right? Then the forward tells me what are the difference in terms of like implementation of the forward path. But in general, if you use something like this, or if you just have a small like a 4 bullet point that says, okay, my model is very special because it does this, this, and that, then it really helps everyone. So it helps our team integrate the model faster, but it also helps other people, other frameworks, other libraries, because they can instantly know, okay, I already support Llama. I know what changes I need to make to have your new model inside my library. Then, of course, you have to provide the weights. I mean, that's pretty standard for open source and open weights. And for that, for us, but probably a little bit biased. Hugging Face repository are the easiest to work with. You can have an organization and you add people there. So that's an example of what we've been working with the Recurrent Gemma team before the release. So they gave us access to a repo like this. And when we have this, it's really easy for us because we don't have to go through crazy lengths to download something that's like behind a gate or a wall. Or we just have access to something we're pretty much at this point everyone familiar with. Then it really helps when you have helpers to explain some things that can be very complicated. So for example, the attention mask is super important. And until a few days ago for the Gemma 3 integration, we had a few issues with the attention mask. And this stems from some complexities with the attention mask when you have image tokens and text tokens. And so if you have something like this, like a simple ASCII character that says, okay, the image token should pay attention to all of the image tokens, for example. But if it's sliding, then it should look like something like this. This helps us a lot as well. Because, for example, if you look at the PalyGemma attention mask, it's very different from what we just saw. So on the left, you have what happens with the prompt, so basically the prefill. But then after you've processed that, the rest of the mask should be completely causal. And if you don't get that right, your generation are going to be very, very bad. Then you should provide us, but if that usually having all of this is usually mean the integration is going to be somewhat easy. But if your model is a bit specific, it helps to have just input and output, so we know what are the tokens that are getting inside the models, mostly the IDs. If we get the tokens, it also helps, because usually the framework used for tokenization is a bit different. So there's tick token, there's sentence piece, and that's mostly, and then tokenizers as well, but that there are 3 different frameworks, and they're not always the same. Then there's a reproducible snippet. So of course, I mean, that's very standard, but that helps a lot. And all of these, we actually use it to create the maintenance part of transformers. So we create integration tests that we always run. And for example, it's not scary, but for example, for Gemma, when you have a sliding window, you need to make sure that you go outside the sliding window, that the generation still makes sense, right? So these are the kind of things that we can create and we make sure are maintained over time. Now let's go a little bit into the steps that happen when we integrate a model. So there can be 3 different parties that work on the integration. So maybe it's you, so you is yourself, an organization. In that case, you're most likely unfamiliar with the transformers code base. But you can control the timeline. Whenever you're ready to put out the model, you just ping us, we do reviews. But it's usually very, very hard to do something like that on your own because you get a review maybe too late, and then you have a lot of changes to do and back and forth. Then there's us, so we do a collaboration. In that case, for me, it's the best of both worlds. And that's how all of the Gemma collaborations have been going, actually. So the Gemma 1, the Gemma 2, the Recurrent Gemma, and Gemma 3. That also creates some friendship. So thank you again for all of the Gemma teams. I think most of the collaboration with you have been going very, very well. And personally, I really like it when we can talk to the researchers or the engineers to ask the specific questions, for example, with the mask. And then we also can do it on our side. But when that happens, we cannot guarantee a day 0 integration. That's because you're not alone. So there are tens of companies that are always asking if they can get a day 0 integration. They don't always have the manpower to do it, so we try to help them. And in that case, it's a lot harder for our team. What happens is we just create a private fork of transformers, and I'm quite happy to say that's the only NDA part of my job. Or we create an open PR when the model is already published. So for example, the 5.4 model was published on the hub with a trust remote code equals true. It just means the code was available on the hub, but it was not integrated into transformers. And when that happens, we strive to make sure the model gets integrated into transformers because we usually check all of the features. So one of the best models out there for vision language model was InternVL, but it was never integrated into transformers, so you didn't have, for example, batched inference. And that causes a lot of problems. And then one of the most underrated tools when you add a model to transformers is the CLI that we have. So if you try to do it without it, you're going to miss a lot of the files that we really need for the core features, like from pretrain or the auto-config, auto-model. And just using this, it's quite simple, and it tells you which model are you basing it off. And here we can link again with, if you compare your model to the Llama model or to all the models in the framework, you can find the closest model, and the integration is going to be a lot easier. Now, where I want to, yeah, that's an example of, for example, auto configs that you cannot invent, right? It's something that has to be done, and you cannot invent that. Now, let's get our hands a bit dirty, so I want to spend a little bit more time on that. It's what happens when you actually do an integration. And that's a tweet from Daniel Hahn that was, I think, 2 days after the first release of Gemma. And it shows the amount of bugs, and it's really not on the Gemma team, it's more like on our transformer side, that were shipped with the model. And so we're super grateful to have the community help us, but a lot of them are very, very, very tricky. And even if we have the integration tests, even if we have whatever I showed you before, where we check the tokens that are input, where we check all of this, shit can happen, right? And so my question now for you is, do you see anything wrong with this? Or can you predict what's going to happen? What is going to be the output of that small snippet? Okay, it's basically wrong. And some of you might have noticed it's because I'm using bfloat16, and you know that bfloat16 is not supposed to be used for big like integers. But the thing is, when you do the rope, you're supposed to, so either you pre-compute the frequency that you're going to use, or you don't. And if you don't, because you want your code to be torch compile compatible, sorry if it's getting super technical, but if you want your code to be torch compile compatible, you cannot pre-compile the frequency that you're going to use that depend on the position IDs. And the position IDs can reach these values, like 8,000, right? And so if you make a mistake, and at some point you have to multiply float32 with the position IDs, if you cast the position IDs to bfloat16, then your model is going to output pretty much shit. And that's something super tricky, because if you just don't know about it, then you won't realize until you just print the output of every single layer that you're trying to debug. Then you have a lot of discrepancies between the, of course, float16, float32, bfloat16, which create very different results. And that's one of the issue I quote every week when someone says, oh, there's a difference between my model and the model you integrated. I'm not getting the same results. I don't know what's happening. And my colleague Joao made a big thread about that and why there are differences. But precision is usually one of the key wall and a key barrier of what can go wrong when you integrate a model. Then recently with the Llama releases, the rope, so rotary positional embedding, has also been giving us a lot of headache. And the thing is, the first Llama release had a license code, so we could not use the formulation that you can see on the bottom. We had to use the one from Eleutheria. They're completely equivalent, but if you use the one with the cost and sign directly, you have to rotate your weights. You have to rotate the query and the key. And that is a big problem. And a lot of people open issues and transformers and say, why are the implementation different? Or they just check themselves the layers of the Llama model, and they say, okay, there's a problem, like the query and keys, they are different. This is one of the first problems. But the second is, if you have query norm or K norm afterwards, then you're also going to have to do some magic to make sure that it works. So sometimes you have to reshape, sometimes you have to do crazy views, transpose and repeat the weights. This is giving us a lot of headaches. And the main motivation behind that is because we kind of had to. We were not allowed, related to the license, to use the first code. And finally, something people underestimate a lot, and we've had tons of issues about that, is that when you want to resize your head, the language model head, or the embedding, you are going to disrupt the distribution probabilities of all the tokens. And there's a super good explanation, so I really recommend you to go on that website, that explains exactly what happens in terms of math and why you're seeing this. But this can really transform the output of your model, and you just end up not being able to generate anything. Thank you, everyone, for your attention.